Hello, kids. Welcome back to school. I thought we'd spend, even though I'm not there today, I thought we'd spend some time reviewing. And I have the perfect problem. It's a new problem, but it reviews two concepts. So it's a really good welcome back, dust off the cobwebs, and get ready to do some math. So first, before we went on break, you were doing long division. We have what we call a polynomial. This is a third degree polynomial. And my instructions are going to be, find me the other roots if I tell you one of them is at -4. So you have two options. You can either do long division or you can do synthetic division, which I think most of you will like better. So if I'm testing the root at -4, I look, if you notice, you have an x to the third, and then you go down to an x. So we're skipping the x to the second term, which means we have to go through and add in a 0 to that. And then I write all of my coefficients out in a row. I start by bringing down the 1, and I alternate between multiplying and adding. So 1 times -4 is -4. Add that to 0. -4 times -4 is 16. -21 plus 16 is -5. And -5 times -4 is +20. And there's a reason why this adds to 0. And that's because I already told you that -4 is going to work because it is for sure a root. Now the coefficients that we have at the end are going to give us, take away a degree, so we have an x squared term now. So I have x squared minus 4x minus 5. And at this point in time, we're down to a quadratic. So we can either factor, if it's factorable, or use the quadratic formula. It is a factorable problem. I have x minus 5 and x plus 1. So now I take a look at these two things, and I know my two other roots are at 5 and -1. So I found 3 roots. Well, one of them I gave to you, and then we found the second root and then the third root. Remember, the degree tells you how many roots you should have. All right, so what I want you to do today, I'm going to go through 2 examples here, but basically we're combining what you guys learned to graph on your quiz with now what we have in terms of finding roots. So now I'm going to combine together. We're going to end up graphing, but now instead of us starting off with a problem that is in factored form, I'm starting you with a problem that's in standard form, and I'm giving you one of the roots, which means you have to go and find the others before you can go and graph. But just as a reminder, some things that we have to remember. We have to remember what a triple root is, what a double root is, and what a single root is. I said that backwards, sorry. And your end behaviors. Are your arrows both up? Are your arrows both down? Is one up, one down, or one, what am I missing? Down, and then up. So you got to remember all of those kinds of things. See, this is the perfect review for your first day back. So we can either use long division, or we can use long division or synthetic division. I'm going to use synthetic because I like it better. So I know I have a root at -2. I'm going to put my coefficients out in front. And I'm going to synthetically divide. So carry down the 1. 1 times -2 is -2. Add 4, so I have +2. 2 times -2 is -4. Add that to 11. I'm going to get -15. And -15 times 2 is perfect. 30. I get my 0 that I want. This is now a quadratic. And lucky for us, this is a factorable quadratic. So I can think about what two numbers multiply to -15 and add to +2. And I am going to get x equals 5 and x equals, -5 and x equals 3. So what I know right now, I'm going to now go through and say, okay, I have these roots. I have roots at the -2 that I gave you. That's 1. The second one is at -5, so that's 2. And then you have a root at 3, and that's the third root. Now, if you go back, if you remember, this is a third degree. and that is a positive. So if you're positive, your right arrow is going up. And since it's a third degree, we're odd, and our arrows are going in different directions. And then I just go back and look. So here I'm going to highlight my 3 roots that I have. And none of them are repeats of each other, which means none of them are double roots. So we have all singles. And singles just go right through the axis on all of them. So I'm going to just kind of draw my roller coaster straight through and connect to my arrow at the top. So basically, it's not really much different from how you started the units. The only difference is I don't give you the problem in factored form. I give it to you in standard form, and you've got to just do a quick little division problem to go and get your roots. Let's do one more as a little bit of a reminder here. So I have a root at -1. I'm going to test that first. Now be careful, because this is a -1 that's going to start. A 1, a 5, and a 3. So that means I'm bringing down a -1. -1 times -1 is +1. 1 times 1, or sorry, 1 plus 1 is 2. 2 times -1 is -2. Bring down that, I get 3. 3 times -1 is 3. -3, I get 0. Now this is a little bit weird. I get x squared plus 2x plus 3 equals your y. And you can either factor this or you can use the quadratic formula. It does not matter. Just if you factor it, be careful that there's a negative out front. So one thing that you have to understand is what you're doing is you're trying to find your roots. So that means your x-intercepts, that means y is 0. So one thing that we can do is just actually flip sides. I know it's kind of weird to think, but if we just took every one of these and moved them over to the side that 0 was on, we then switch basically and the 0 comes on the left-hand side, and all of these would change sign. The reason why I did that is I actually prefer to factor when my x squared term is positive. I think it's easier to factor that way than have the negative out front. So now that I'm in a form that's factored, I know I have 2 numbers that multiply to -3 and add to -2, and that's going to be -3 and 1. So I'm going to have roots at x equals 3 and x equals -1. So as I go through and I start thinking about graphing it, I have to check a couple of things. I have a root at x equals -1. I have a root at 3, and whoa, I have another root at x equals -1. And the fact that you have it twice tells you that you have a double root at x equals -1, and x equals 3 happens once, so that's a single root. So you're going to catch your double and triple roots this way if it comes up twice. So I gave it to you once, and you got x equals -1 again. So there's your double roots. So I have x equals -1 that I can plot, and I can plot x equals 3. I'm going to look at this leading coefficient. It is a third degree, and it is negative, which means my right arrow is going down. Third degree means your left arrow has to go the opposite side. So the left arrow is going to go up, the right arrow is going to go down. If I take a look, my -1 is a double root. So if I'm starting from the top, I've got to make that parabola come down, hit the axis, and bounce back off. There's my double root at -1. And then I have a single root at 3, which means I'm going to go straight through 3, and I'm going to come down, and I'm going to connect to my other arrow. So you're combining the dividing with your graphing. And I want you to try a couple of these. It's great review because a couple days you're going to have a test on this stuff. So, happy graphing.